2.2 Law of Sines. Okay, so let's look at next example. We are given two sides and the angle between them, and let's just first see what happens if we try to use the law of sines here, and maybe you understand why we have another one. So I'm given an angle, right? And I don't know this side, and I'm giving two more sides, and I don't know these angles. So any way that I look at this, if I try to make any pairings, so let's say for example I try to do this, and I'm going to fill in the parts that I know. So A is unknown, okay? I do know what the sine of 30 is. And then B I know, but I don't know what the sine of B is. So I have two unknowns in here. And well let's try C. So if I tried C, C would be 5. But again, I don't know what the sine of C is worth, so, or what C is, so I don't know what the sine of C would be either. So there's just no way to do this. So you don't have, so what we're missing is, we are missing a complete pair. So we cannot use the law of sines. So we have the law of cosines. So the law of cosines, I'm going to write down what they are, what it is. And we have more than one version of this, but that's just a changing of the letters, sort of. So it's a squared equals to b squared plus c squared, so it's a little similar to Pythagorean theorem, right? Minus 2bc, and then the cosine of a. Now we could also have that in this form. We could have, well, b squared, so let's see, then that should probably be a squared plus c squared. And then here, still 2, and it's bc squared would be bc, so this should just be then ac, and then it's the cosine of b. So the angle and the side here, they match up at the end. And then the last form that we have for that is we could also have c squared equals, so I'm not using a squared and b squared, so that means I'll need 2ab, and then the cosine of c is here, and then I need the angle c over there. Okay, you should be able to prove this. Alright, so let's see, how can you prove it? So we're going to start very similar. We have an acute triangle, it's easier to do in the acute. C, altitude down, so there's your perpendicular height. So that's C, I'm going to call this, so from here to here is C minus X. From here to here is then X, and H, A, and B. So let's see, what do we have? Well, I can say that H squared plus X squared is equal to A squared, right? This H and that X squared must be A squared. Okay? I'm going to do the same thing on the other side. So then it would be, so let's do that one in blue. So if I say H and C minus X squared, so H squared plus C minus X squared is equal to B squared, because that would be the hypotenuse over there. Let's see, there's an h squared here and an h squared there, so I'm going to now stick to blue. So let's say that h squared is then a squared minus x squared. So I'm going to replace this, I'm going to replace h squared with a minus x squared. I'm going to FOIL c minus x, so keep in mind that c minus x times c minus x would be c times c is c squared. I get minus cx, but I get it twice, so minus c times x, and then x times x with a negative that cancels. So I get plus c squared minus 2cx plus x squared is equal to b squared. So here's a negative x squared and a positive x squared, so they are going to cancel. So I get a squared plus c squared minus 2, oh, forgot the 2, minus 2cx is equal to b squared. Well, that's pretty close to one of those. Which one is that? That's the second one, right? Hopefully I plan to write in blue because of that. So b squared, got that. A squared plus c squared, I got a squared and c squared, minus 2 and then a c, so a minus 2c, and then I have an x here. So somehow I need to get rid of this x. So this x is the side from here to here. I'm actually going to put it over here for now. Okay, I can write this x in terms of x is an adjacent for this angle. So I could say that, let's see, that's an adjacent, right? So the cosine of b is x divided by a. So if I think of this as over 1, I can multiply this way. So x is actually a times the cosine of b. So I'm going to use a cosine b instead of x. So now I get a squared plus c squared minus 2c, and that's a cosine b equals b squared. And that really is the law of cosines. So I'm going to clean this up a little bit, write it in the order that we had above. So that's minus 2. I'm going to bring the a first, then the c, and then the cosine b, because keep in mind you can multiply in any order that you want. So whether you do c times a times cosine or a times c in cosine b, it doesn't matter. And I move the b squared to the other side, and that is how you can prove that the law of cosines has this structure. And then clearly you could rotate the letters and do it for every single one of those, but hopefully you'll take my word for it that you can do this also for the a squared and the c squared one. Okay? So proving it, something you should be able to do. So let's use it. Okay, so let's use it on the triangle that we started with. So let's see, what are we given? We're given this angle, B, C, and then A over here. And let me cheat a little bit and let me grab these. And bring them down here for a moment. Okay, so why did I do this? I want you to see something here. So we're only given one angle, right? A is the only angle that we're given. And you have to use an angle. So because of that, I am going to have to use this one. Okay, I have to use that one. And that works out actually because, look, I don't know what A is, but I got, so I don't have this spot, but every other spot I have, because B squared would be 4 squared, C squared would be 5 squared, minus 2, B is 4, and C is 5, and I'm multiplying by the cosine of 30 degrees. So I can figure out what this is. I can do a squared equals, plug this in my calculator, hit enter, I get 6.359. Take a couple of decimals with you, take the square root, so that gives you a is 2.52. Okay, so a is 2.52. Okay. I would strongly suggest at that point that you use the law of cosines again. Unless you really understand all this stuff after you've worked with this a while and you can sort of reason your way through it. And I will show you here in a moment what I mean with that. But at this point, I would go back, and so I'm going to find out what b is by saying, well, b squared is a squared. I'm sorry, I'm going to find angle b. So b squared I do know, right? I know that b squared, which would be 4 squared, is a squared, and I just found out that a squared was this number here actually. Yeah, so now we'll just use 2.52, and when we square it we should get that back. So it's a squared plus c squared, which is 5 squared, minus 2 times a times c times the cosine of b. If you do the math here, so if you square this and square that and you add it and subtract it on this side, you should get a negative 15.25 equals, and then over here you get a negative, and then when you do 2 times 5 you get 10 obviously, so that's minus 25.2 times the cosine of b. So So that means that the cosine of b is a negative 15.25 divided by a negative 25.2, and then means that the inverse of that, so angle b, will be the inverse cosine of that value. So if you plug that in the calculator, you should get angle b to be 52.4 degrees, rounded more or less. Okay? So what else do we need? So b is 52.4, so we got everything except c. So c would then be the 180 minus 30 plus 52.4. So c would be 180 minus 82, 83, so that's 97.6 degrees. Okay. Alright, so maybe you're wondering why I use the law of cosine twice, because at this point, so once I got here, I had a pairing. And we said this is the reason we have the law of cosines, we don't have a pairing, but at this point I had an angle, and I had a side that went with it. So why not use the law of sines at this point? Well, it's not that you cannot use the law of sines, but the main reason is that the cosine is going to eliminate any guesswork sort of in terms of what you're gonna what angle you get. If you can think back to when we did the ambiguous case, the angle that the sine is going to give back to you is always going to be the acute angle that you're looking for. Okay, and in this case I did find b first here. Now b from the picture you can see is acute. So I could have found b with the law of sines, and then definitely that would have been the right answer. But on the other hand, if I had tried to find angle c at this point, with c being an obtuse angle, I would not have found the right angle for c if I had done that. And maybe I can illustrate that. So if I had done 2.52 divided by the sine of 30, right? Because that's a over a, and then I'm going to use c, 5 over the sine of c, then the sine of c would be 5 times the sine of 30 divided by 2.52, so c would be the inverse of that. And if I put that in my calculator, let's see if I can do that. The inverse sine of 5 times the sine of 30 divided by 2.52, and when I put that in my calculator, and you should check this, I get c equals 82.8 degrees. Notice that that is a supplement of 97.6, because together they need to add up to 180. So you have to be really careful when you do this. If you start with the law of cosines, I think you're better off using the law of cosines to find the other missing angle as well, so that when you do this, you definitely get the right answer. Okay, the law of cosines would have found the right angle for C either way. But you know, if you get a good handle of this, you can sort of see it. And drawing the picture really helps. Having the acute angle here does tell me that, you know what, I could have found the sine, or used the law of sines for B. I would have found 52.4. If I would be looking for C here, and I would be using the law of sines, I need to understand that C is larger than 90. So, you know, it's up to you guys. I'll be safe. Alright, so with that in mind, let's look at this triangle over here. It says solve the following triangle. This one I'm not going to solve the whole way through. So let's think about this for a moment. So there's no way that I have a pairing. So I have to find something here, right? Let's see, I do have cosine b here, so let's find out what b squared is. So b squared would be a squared. Let's label these. So that's a, and that's c. So it would be 4 squared plus 6 squared minus 2 times 4 times 6 times the cosine of b. And I know that b is actually 105.2. So that means that b would be, it's a rounded 8.0. Okay, so b is 8.0. Okay, notice that b is an obtuse angle. Okay, you can only have one of those in a triangle. So at this point, right, so since b is larger than 90, the law of sines will work here. So you could use the law of sines. You could say b over the sine b. You know what? I might as well finish this. Is c over the sine c. So what is it? B was 8. So 8 divided by the sine of 105.2 is equal to 6 divided by the sine of c. So I'm not sure what happened there. So the sine of c is 6 times the sine of 105.2 divided by 8. And that is approximately 0.729. So that means that c is the inverse sine of 0.729. So c would be 46.4. So if you have c at 46.4, then you can find a by doing 180 minus, so this is going to find a 180 minus 46.4 plus 105.2, and that's what? That's 140, 151.6, so that's 28.4, I think. 28.4 degrees. Okay? Alright, so here's case 3, or sorry, case 4, and I forgot to put that on there, so let's blot this off a little bit. So this is case 4, and that would be side, side, side. So what do you do if all sides are given? Now keep in mind that I just had this little story about finding or choose angles, etc., etc. So if you're given the 3 sides, I think that you really should start. So this is the safest bet. So the safest method is find the largest angle first. How do you know which one's the largest? Well, it's opposite the largest side. So if that's 15, then that's an A. So I'm going to find angle A first. And this one's opposite C, and this one's opposite B. So I am going to do A squared. Let me write it down once for you, one more time. So it's going to be A squared is equal to B squared plus C squared minus 2BC, and then the cosine of A. Now the nice thing about the cosine is that it will give me the right angle. Doesn't matter if it's acute or obtuse. So in this case, I'm going to get the, I should get an obtuse angle, and that should mean that I should be solving for a negative here at some point. So let's see if that works. So 15 squared, B 11 squared, plus C 8 squared minus 2 times 8 times 11 times the cosine of A. So now I'm going to do, on the calculator, I'm going to do 15 squared minus 11 squared minus 8 squared. And when I do that, I got 40 equals, and then here you do 8 times 11 is 88 times 2, so it's a negative 176 times the cosine of A. So when you divide that, the cosine of A should be 40 divided by a negative 176. And that's what I meant earlier with I should be solving for a negative here at some point. So if the cosine of the angle is this, then the angle will be the inverse cosine of 40 divided by a negative 176. And this is how I would put it in my calculator. I would try to avoid rounding as much as I can, and when you plug this in, you get 103.1 degrees. Okay? Alright. Once you have one angle, then now you could go back and use the law of sines. Okay, so you can use the law of sines because there can only be one obtuse angle, so the law of sines should work from here on out. And I'll let you do that because I have one more quick one. So sometimes math books are sort of sneaky, and math teachers can do the same thing. So here's your last picture. And I said that this should be a quick one. Now, the reason this is quick is because it's telling you here that B is 3 and A is 2. Now let's reconstruct this triangle a little bit on our own. So if that's 6, so I'm going to make it a little bit longer. So that's 6. So half of that is 3, right? So B should be about half of that. So B is going to be about half of that. So I'm going to put B over here. There's 3. And then A is 2. Well, so if that's half, then A would be over here. So that's 2. So let's put the sides here up one more time. So they're saying that B was 3, A was 2, and C was 6. How in the world is 3 going to meet the 2 if you rotate them through? Think about it. Somehow they have to rotate. I mean, if you go from here to here and you go 3 in that direction, and you go from here to here 2 in that direction, aren't you going to have a gap of 1 still in between them? So this is not possible. Okay, but the picture sort of shows that it is. So, but that is not possible. Just look at the picture before you start. You would be solving here. So definitely, if you did what I said earlier here, you would be solving for angle C, right? So you would be solving here for angle C with C squared is equal to A squared plus B squared minus 2AB cosine C. You're going to get the cosine of C equals, and it's probably going to be negative, but it's going to be bigger than 1, like a negative 5.7. And the cosine can't be a negative. It's got to be between a negative 1 and 1, so you cannot be in a negative 1 point, whatever. That's what you would get if you solve this outright, but you don't have to. Just look at the picture before you start. Okay?